Good evening, everyone. This is exercise related to acid, base, and the types of oxides. So in this session, I'll solve half of this exercise. So starting with question 1, we have dilute sulfuric acid, which is a typical acid. A student had access, like more than enough, dilute sulfuric acid to a sample of copper 2 carbonate. So whenever acid react with carbonate, the general reaction, whenever any acid is there mixed with metal carbonate, the observation, it will produce a salt, it will produce water, and it will produce carbon dioxide. The salt which is produced here, because it's a sulfuric acid, so it will produce sulfate salt. So copper carbonate react with sulfuric acid, give copper sulfate, water, and carbon dioxide. We have to give 3 observations the student would make. So what are the observations? First, because there's a gas given up, you can see here. So there will be bubbles, phase, effervescence. This excess of excess of acid is used, so this all metal carbonate will react or disappear. And because it's a transition element like copper ion is there, so it will form a colored solution. So the solid dissolve, there will be fizz, effervescence, bubbles, and it will form a colored solution, or a blue colored solution will be formed. Give the name of all the products. So copper carbonate react with sulfuric acid. As a result, it will produce copper sulfate, copper 2 sulfate. Water is there, and then carbon dioxide. Some oxides of some elements are listed, as you can see: carbon monoxide, carbon dioxide, sodium. Answer the following questions. You can use oxide once, more than once, or not at all. So the non-metal oxides are acidic, like non-metal oxides are either acidic or neutral. So this is a non-metal oxide. This one is a non-metal oxide, silicon oxide, a non-metal oxide, phosphorus non-metal oxide, sulfur dioxide. Non-metal chlorine oxide is also a non-metal. And then we have metal oxides are either basic or amphoteric. So sodium oxide, magnesium oxide, aluminum oxide, and chromium oxides are the amphoteric oxides. And non-metal oxides are acidic, as the non-metal is there. So this will be acidic or neutral. So carbon monoxide is neutral. Rest all of them are acidic. Then for metal oxides, aluminum, zinc, and lead are the amphoteric oxides. These are the amphoteric oxides. Rest of them are basic oxides. The question is, which is the main cause of acid rain? So acid rain is caused by acidic oxide. So these are all acidic oxide. But what is the main cause of acid rain? As a sulfur dioxide released by either combustion of the fossil fuel or sulfur containing fuel, it produces sulfur dioxide. And that sulfur dioxide mixed with water forms sulfurous acid, which leads to acid rain, which would give a solution with a pH 14 when added to water. So the basic oxide, so group 1 metal oxides are highly soluble. So as a result, it will make a solution strong alkali, which is colored. Colored compounds, if contain a transition element, so this contain transition element, so chromium oxide. What is the main impurity in iron ore? That we'll discuss in metal topic, but that in this case, just the answer is silicon oxide. In detail, we'll discuss the topic metal, which is amphoteric. Amphoteric means can react with both acid and alkali. That is aluminum oxide. And the last one, which is neutral, so carbon monoxide is a neutral oxide. Then we have amphoteric oxide and neutral oxide are different from each other. What is meant by amphoteric oxides? So the amphoteric oxides can react with both acid and alkali. where neutral oxide does not react or no reaction with acid and alkali. In question 2, dilute nitric acid behaves as a typical acid in some reaction but not in other reactions. When dilute nitric acid behave as a typical acid when reacted with copper oxide or copper carbonate, describe what you see if excess of a nitric acid is added separately to the solid sample of copper carbonate. So if copper carbonate plus nitric acid, the product will be copper nitrate plus water plus carbon dioxide. So again, you can see a similar question. The previous question, it was copper carbonate was reacting with sulfuric acid, but now with nitric acid. So the observation with carbonate, the solid dissolve, there will be phase bubbles effervescence and it will form a colored solution or a blue color solution. And when copper 2 oxide, metal oxide react with acid, it will give salt and water. So when metal oxide is reacting with nitric acid, it will give copper nitrate plus water. But there is no gas given off. So you cannot say fizzing or bubbles. Solid dissolve. What else? Uh, because as you can see, a transition element salt is there, so it will form a colored solution. If there was a group 1, 2, or 3 salt, then the solution will be colorless. So it will also form a colored solution. These are the observations. In part B, when dilute nitric acid is added to a piece of copper and is heated, the reaction take place and that copper to nitrate is formed. The part of a chemical equation has been the reaction between copper and nitric acid is shown. The chemical equation by complete the chemical equation by inserting the formula for copper to nitrate and balance the equation. So first we have to insert the formula for copper to nitrate. Copper to nitrate means the valency of the copper is +2. So the formula for copper to nitrate, copper is +2 and nitrate, the molecular ion with a -3. So when we cross multiply, the formula is CuNO3 in a bracket 2. So copper to nitrate is CuNO3 in a bracket 2. When we balance these equations, we try to balance oxygen followed by hydrogen and then at the last other element. So when you check, because we can only put a number here to balance, how many oxygen are for, so balancing a equation, it will be oxygen followed by hydrogen and then other elements. So when you check oxygen 4 and 2, 6. And then this 3 multiplied by 2 as well, that is also 6. So total hydrogens, total oxygen on the right hand side, we have 12. Where 8 multiplied by 3, that's 24. So we have 24 oxygen. So we want to make it 24. So here, because this 4 plus 2, already 6 are there. So in this case, we have to change, we have to make it 18. So 3 multiplied by 2, 6. And then if it is multiplied by 3, so it will become 18. So oxygen on the right hand side is 18. Oxygen on like first 3 multiplied by 2, 6. 6 multiplied by 3, 18. 18 plus 4. Like this is, these are 2 oxygen, 4 oxygen, and then here 18. So 18 plus 4, 22, and plus 2, 24. So oxygen is balanced. So for balancing equation which involve an actual reaction of acid with metal or metal oxide, metal carbonate or hydroxide, we start balancing with oxygen. Then followed by hydrogen. Hydrogen is actually already balanced here, 4 multiplied by 2 and 4, 8. So left and right hand side we have 8. Then copper we have to balance other element. Copper 3 here, so we put 3. Copper is also balanced. So this equation is balanced in terms of all the elements. How this reaction of a nitric acid with copper different from typical metal with typical acid. Like As you can see, when the typical metals, what is the general reaction when any metal is added to acid or acid is added to metal? It will give salt and hydrogen. That is a product. But in this case, a metal mixed with acid, it gives us salt, water, and nitrogen monoxide. So it means how this reaction differed. So typical metals, it gives hydrogen when metal react with acid. But this one is not giving a hydrogen, so that's a difference between them. In question 4, lead to oxide, which is insoluble. A student add lead to oxide to nitric acid until the lead to oxide is in excess. Excess means like more than enough for the complete reaction or too much for the reaction. So what is meant by the term excess? The term excess means like it is more than enough for a complete reaction. How the student know when the lead oxide is in excess? Because as you can see, like nitric acid, which is aqueous, student is adding a solid lead oxide. So when all the acid reacted, there will be no more lead oxide react, so the solid will appear. So how the student know that the lead oxide is in excess? When the solid stop dissolving or stop reacting. So when the solid stop dissolving, or we can also say reacting. Write a chemical equation. So chemical equation should be symbolic until unless they mention that write an word equation. Otherwise, always if it's a chemical equation, be symbolic. So we have lead oxide is there, lead 2 oxide. So lead is +2 and oxygen is group 6 -2. So the two have the same valency. So lead oxide is PbO. Nitric acid, HNO3. So when metal oxide react with acid, it will give salt. So which salt? Nitric acid give a nitrate salt. So you have to write a formula for lead to nitrate. So lead is +2 and nitrate is -1. So when we cross multiply, it will be PbNO3 in a bracket 2. So lead to nitrate, PbNO3 bracket 2 plus water will be there H2O. Equation must be balanced always whenever you write. So start for balancing, start with oxygen followed by hydrogen and then other elements. So 3 multiplied by 2, 6 and 7. Here we have 1 and 3, 4 are there. So if I put 2, so 3 multiplied by 2, 6 plus 1, 7. So oxygen is balanced. What about hydrogen? 2 here, 2 there. So that is balanced. And then the other lead is also balanced and nitrogen 2 is also balanced. So when we balance oxygen, the whole equation is balanced. For reaction of acid with alkali base, start balancing with oxygen followed by hydrogen and then the other elements. In question 5, the sulfuric acid react with hydrocarbon to form benzene to produce with a hydrocarbon called benzene to produce a benzene sulfonic acid, which is C6H5SO3. H is there, and benzene sulfuric acid is a strong acid which ionize to produce the hydrogen ion, and C6H5SO3, C6H5 and SO3, the 3 is here actually, this 3 is subscript and the charge is -1. What is meant by the term strong acid? The term strong acid means the acid which ionize completely. The acid which ionize completely we call strong acid. And donate proton and ionize completely. Describe how 1 mole per dm cube solution of how to show that it is a strong acid. So how we can identify the nature of a solution? We can use indicators, universal indicator. It will show a pH like 1 to 3 or 0, 0 to 2. So we can check with universal indicator. And when we check with universal indicator, it will show a pH from 0 to 2, or it will, you can say 1 to 3 also acceptable. Then write a chemical equation for reaction between benzene sulfonic acid and sodium carbonate. So whenever any acid react with carbonate, it will give salt, water, and carbon dioxide. So sodium carbonate is Na2CO3. Benzene sulfonic acid, C6H5, then SO3, and then H is there. So C6H5, SO3, and then H. When acid react with metal carbonate, it will give salt. So which salt will be there? Because it will give, the hydrogen will be replaced. Normally, when we have, like, say an acid, say if it was normal sodium carbonate, say it was reacting with hydrochloric acid. So what will happen, this hydrogen will be replaced by the metal, and it will give sodium chloride, NaCl salt. It will produce water and it will produce carbon dioxide. Now we have sodium carbonate, which is again Na2CO3, and it is reacting with benzene sulfonic acid, which is T6H5SO3H. So this H is the one which will be replaced by the metal. So metal will take position, and C6H5SO3 is having a valency of -1, and sodium is +1. So they will have the same, like, valency. So we write as it is C6H5SO3 in Na. That will be a salt. Then it will be water, H2O will be there, and carbon dioxide, CO2 will be there. So whenever acid react with metal carbonate, it will give salt, water, and carbon dioxide. Then the second part is balancing. Start balancing with oxygen followed by hydrogen, and at the last other element. So 3 plus 3, 6. Oxygen is already balanced. Then carbon is balanced. Hydrogen is 5 plus 1, 6. And here 5, 6, 7 are there. So what we can do, because 2 sodiums, if I place 2 here and I place 2 here, so this equation is now balanced in terms of all the elements. In question 6, copper to nitrate can be made by reacting copper to carbonate with nitric acid. One of the product is carbon dioxide. Write a chemical equation for reaction between copper to carbonate. So copper to carbonate, copper is +2 and carbonate is -3. CO3 with a charge -2. They have the same valency. So copper carbonate will be CuCO3. Reacted with nitric acid, which is HNO3. As a result, it produces copper nitrate. So copper nitrate salt, because copper is +2 and nitrate is -3 with a charge -1, NO3 with a charge -1. So it will be CO, NO3 in a bracket 2, plus water, which is H2O, plus carbon dioxide, CO. And then we balance equation, start with oxygen. We already did this previously. We will start with oxygen followed by hydrogen, and at the last, other element. The carbon dioxide is added to the air by living things. Name a chemical process by which the carbon dioxide is added. So the process by which the carbon dioxide, that is respiration, and how it is removed, photosynthesis. So by respiration, then photosynthesis, then dilute sulfuric acid react with a base metal and metal carbonate. So if write an equation for the reaction between magnesium, equation for reaction of sulfuric acid with each of the following. Magnesium hydroxide. So magnesium is group 2 and hydroxide is OH. So magnesium hydroxide will be MgOH in a bracket 2. So the first one, magnesium hydroxide, MgOH in a bracket 2 reacted with sulfuric acid, which is H2SO4. So metal oxide, hydroxide plus acid gives salt. Sulfuric acid gives sulfate salt. So magnesium sulfate, MgSO4, because the valency of magnesium is +2 and sulfate -2, plus water H2O. And the equation must be balanced. So start balancing with oxygen, followed by hydrogen, and at the last other element. 4 plus 1, 5. Here we have 6. So we have to balance oxygen first. Hydrogen 2 multiplied by 2, 4 are there. So if I put 2 here, so oxygen is balanced. Because 4 and 6 and hydrogen is also balanced, and other elements. When metal react with acid, it will give salt and hydrogen gas is there. So zinc plus sulfuric acid gives zinc sulfate, ZnSO4, plus hydrogen will be H2. This equation is already balanced. Then sodium carbonate react with sulfuric acid. So when metal carbonate react with sulfuric acid, it will give salt, water, and carbon dioxide. So Na2CO3 plus sulfuric acid, which is H2SO4, gives salt, sodium sulfate. Sulfate is -2, so sodium is +1. That's why sodium sulfate is Na2SO4. Salt plus water, which is H2O plus carbon dioxide, CO2. And we balance the equation. Sodium is 2. Oxygen, we start with oxygen. 4 plus 3, 7. So it's already balanced. Hydrogen is also balanced. Sodium is also. So rest all of them are balanced. So this is the product when acid react with metal hydroxide, metal, and metal carbonate. In question 8, ionic equation is there. Explain why phosphate ion is acting as a base. The definition of a base is a proton acceptor. So H2SO4 is donating proton and phosphate ion is accepting proton. So we'll say because it accept proton. 1 mark is for accept, 1 mark is for H plus, or better use a term proton. In question 9, propanoic acid is a weak acid. The equation represented in this equation reaction with ammonia. So why propanoic acid behave as an acid and ammonia as a base? So as you can see, it was COH become CO. So what happened? It donate proton. And NH3 become NH4, so it accept proton. So you'll say propanoic acid is donating proton, where ammonia is accepting proton. The weak base means it ionizes partially. If it was ionized completely, then it will be a strong acid or a strong base. Then in question 10, we have the different reactions are there. When calcium carbonate react, we have to complete a word equation here. When calcium carbonate is reacting with sulfuric acid, give calcium sulfate plus water plus carbon dioxide. Describe how we can test the water entering the cave. It contains a sulfate ion. So test for sulfate ion, we will add barium nitrate. And it will give white precipitate. How could you show the water entering the cave has a high concentration of hydrogen ion? So if it's having a high concentration of hydrogen ion, means it will be acidic. And so how we can say that it is acidic? So we can use universal indicator, we can use the pH meter. So we can use universal indicator. And the pH will be less than 3. If it's a high concentration, means contain more ions, hydrogen ions or lower pH. We have 4 different bottles. One is ammonia, another one is a hydrochloric acid, another one is sodium hydroxide, and then vinegar. So what is aqueous ammonia? Aqueous ammonia is a weak base. Hydrochloric acid, even it's a dilute, it's a strong acid. Sodium hydroxide is a strong base or alkali, and the vinegar is the weak acid. So we have to select aqueous ammonia weak. We have 1, 4, 10, and 13. So it's a weak base, so that's why it is 10. Hydrochloric acid is a strong acid, so 1. Sodium hydroxide is a strong base, 14, and vinegar is a weak base. Vinegar is a weak acid, that's why it is 4. So we have, or 14 is not there, 13 is there, so I cannot write 14. It should be 13 here. In part B, the following apparatus is there to investigate the electrical conductivity. Dilute sulfuric acid is a strong acid. It was replaced by the weak acid. What two ways the different? Because weak acid contains few ions, so it will affect the intensity of the light emitted out from the bulb. So the bulb will light intensity decrease or it will be dim, and there will be slow bubble formation. When nitric acid is added to water, the following reaction takes place. So nitric acids are like it become NO3, so it means it has donated proton. So name the particle which is transferred, that is called a proton, and the formula for proton is H plus, because hydrogen atom is having one proton and one electron, but the proton means H plus because hydrogen lost that electron, so it is left with only one proton. That's why it's known as H plus. So these are the first 7 pages from exercise acid, base, and oxide.